All right, class, let's take a look at Chapter 6, the Scatterplots, Association, and Correlation chapter. This is an important chapter in this book. So we're looking at scatterplots, and you've probably seen scatterplots before. They may be the most common and most effective display for data. It lets you see like patterns and trends and relationships in data. And scatterplots are the best way to observe the relationship and associations between two quantitative variables. So they have to be numbers on both of them. Both of the variables you're looking at have to be numbers and they have to be quantitative. So when you're looking at scatterplots, you're going to find four different things about the scatterplots. The strength of the relationship, that's the strength of the association, the direction of the association, the form of the association, and any unusual features. You can remember that by Fuds like Elmer Fudd or Duff like Hillary Duff. When asked about association in scatterplot, that's what you should write about. So scatterplots, let's look at strength first. If you have a strong relationship between two variables, you should have really tight clusters that look like this, where all the dots on the scatter plot are really close together. If you have a moderate relationship between the two, a moderate association, you should see something like this. Kind of moderately spread out. And if you have a very weak association, you should see it just all over the place. And I gave you a couple of examples here. Like something that would be very strongly associated would be like the number of paychecks I've had this year versus the amount of money I made this year. These numbers are really low right here. I'm a teacher, so. And as the paychecks go up, the money goes up the exact same amount, right? So it almost makes like a perfect line. Most variables won't do that, but these are like directly related to each other. They're actually perfectly correlated, and we'll get into correlation later. They would have a perfect correlation score because they're directly related. Each paycheck gives me the same amount of new money, and the money will go up at the same amount each time. And that means as the number of paychecks go up, the number of money I made this year goes up. Not by much, but it does. And then we're going to look at two that aren't associated at all, and the dots are going to be all over the place because it's random, right? They could be anywhere. They have nothing to do with each other, like the number of corn dogs sold, comparing it to the number of home burglaries in each given week or month or something. They have nothing to do with each other, so the dots will be all over the place. But if they're very strongly correlated, it'll make a straight line like this. I'm pretty sure that the number of corn dogs sold wouldn't have any effect on the number of home burglaries. They wouldn't have any relationship to each other, right? So that's just an explanation of how those graphs, how the scatter plot works. We're looking at two different variables. Okay, and at one extreme, the points are going to be really tightly packed like this, like my paychecks versus amount of money that I made. It was really tightly packed, like almost a perfect line. And so at one extreme, the points appear to follow like a single stream, and that's a very strong correlation or association. And at the other extreme, where there's almost no association, you have just all over the place. That's almost no correlation right there, or no association. So that's the next thing we're going to look at is direction. A trend rising from the lower left to the upper right has a positive direction, and a pattern that falls from the upper left to the lower right has a negative direction. So let's take a look at some examples of that. This one would have a negative association or a negative correlation. This is the NOAA predicting how hurricanes will go, and this is their error rate, like how the prediction errors that they made. And you notice as year goes up, as we get further and further on the years, the prediction errors go down. They're getting more accurate, right? So these two are associated with each other. There's a pretty good association there. Those dots are pretty close. And you'll notice on these scatter plots, you can almost kind of like draw a line in your head like that. I want you to think about that later, because in the next chapter, we're going to be drawing that line exactly. There's an actual formula to come up with that line right there. And we're going to talk about that in the next chapter, a regression line. So now let's look at a positive relationship. That means as the years go up, the amount of responding yeses go up. So this one is, let's see, the association between the year since 1900 and the percent of people who say they would vote for a woman for president. Wow, there's still about 10% of people that wouldn't vote for a woman for president. That's interesting. I thought all those people would be gone by now, but so I mean, this is an obvious association here. As we go on in the years, more and more people would vote a woman for president because the views on that stuff have changed in the last 60 years. Back here we got everybody, women should stay in the kitchen back here, but we've changed a lot since then, and we should have, so makes sense. The obvious association here makes sense. All right, so the next example shows a negative association between central pressure and maximum wind speed. So we're talking about like hurricanes here. Hurricanes. And as central pressure increases, the maximum wind speed decreases. This is a negative association. So it starts to go down as the pressure goes up. I don't know if you ever remember about hurricanes. They always have it listed, the pressure, in millibars right here. And when that pressure starts getting really low, and they notice that the pressure is dropping, they know we're about to have a really bad hurricane. It's about to get nasty. So that makes sense. As the pressure gets lower, the wind speed gets higher. They have a negative relationship to each other. So yeah, that is direction, like positive or negative. And the association may be flat or horizontal, where it isn't increasing or decreasing. We'll encounter that pattern when we start doing residuals in chapter 7. So we'll get into that a little later, but this is like a horizontal one. It don't have a positive or negative. The form can be linear or curved. Now in on level, we're focusing mainly on linear. We might get into curved a little bit. If there's a linear relationship, it'll appear like a cloud or a swarm of points, but it has like a consistent straight form, and almost in your head you can draw a line, like I said. And you'll be able to do that if it has a linear relationship. If the relationship isn't straight, but it curves gently while still increasing or decreasing steadily, we can actually find ways to make it more straight, or we can do a different type of regression instead of linear. Now see how it makes like a curve like that. And we won't run into a lot of data like that in on level. That will be more AP that will run into a lot of more curved data. But yeah, that can absolutely happen as well. That means it doesn't have a linear relationship. It might go up like exponentially or quadratic. If the relationship curves sharply like this, a linear method is not going to do anything for you. See, like if it does like this and this, there's some sort of weird relationship going on that is definitely not linear. Unusual features, look for unexpected things. You'll see some unexpected outliers in data, and you'll wonder what the heck's going on at that point right there. And it'll make more sense when you see like the two variables and be like, what happened at that point right there? And an example of such a surprise is an outlier. It goes away from all the other plots on the data. You got all these points kind of close together, and then you got one way off by itself. Another thing that could happen is like a cluster or subgroups. Like there's a cluster of data and then like a gap and then another cluster or something like that. It looks like a bunch of data is clustered up in one spot. That's an unusual feature. And there's probably some sort of real world reason why that's happening. See, this would be an unusual feature, that outlier right there, because both of the numbers are so high. And this would be an unusual feature as well. That one piece of data that is way off there. is a outlier in this instance. Kind of like the last chapters, right, where the outlier was way away from everything else. This is very similar. An outlier is going to be way away from all the other ones, and you definitely want to take note whenever you see them, because they're going to throw your data off, the outliers. And there's usually a couple of reasons for outliers in real life. One thing that could happen is just something weird happened, or the data was inaccurate. You know, the data being inaccurate could cause something like this, or just something really weird that's way different than everything else. That could be as well. A lot of times these get thrown out because they're considered to be inaccurate. It's important to determine which of the two quantitative variables goes on the x-axis and which is on the y-axis. So the determination is made based on the roles played by the variables. When the roles are clear, there's an explanatory variable and a predictor variable that goes on the x-axis. That's a predictor or explanatory. And then there's the response that goes on the y. So think about it like this. The x-axis is going to be the explanatory. It's the predictor. As this goes up, the y one responds and does something. It's almost like the explanatory is causing the response. The rules that we choose for variables are more about what we think about them rather than the variables themselves. Just placing a variable on the x-axis doesn't necessarily mean it explains or predicts anything, and the variable on the y-axis may not respond. They may not be causing each other. They may be associated, but one is not causing the other. We'll definitely catch on that later. That's a big point in statistics. All right, so the next thing we will do is example 1. So get example 1 ready on your sheet, on your outline.